Okay, good afternoon, everybody. Thanks for coming along to this session. My name is Mike Roberts. I'm half of a New York City-based consulting company. My business partner, John Chapin, is also here. We help people be more effective with the cloud, is sort of the most brief way I can describe it. And that can mean a number of things, typically starting with architecture review, but we have a various amount of experience in a lot of different areas. So helping people be more effective with the cloud is the best way of describing it. You can contact me at MikeBRoberts, and that's our web address. Also on my Twitter right now, the last tweet I put up is a bunch of resources for this talk. There are a fair few links and references, and also links to the slides. So if you're interested in some of the things I've been talking about today, then grab some of the resources from there. But let's get going. So just so we start, so we're all on the same page. This is a serverless talk, and so I need to just briefly talk about what I think serverless is. There's sort of not a one-size-fits-all solution that everyone agrees on. So here's a quick refresher for those of you that are using some serverless technologies, and maybe the briefest of brief introductions for those of you that are not using serverless. So serverless computing is all about building systems using serverless services. Okay, what are serverless services? Well, serverless services are functions as a service and backends as a service. Okay, I'm trying not to be too obtuse here, so I'll try and explain what these things are. Functions as a service is what everyone thinks serverless is. So this is Amazon Lambda, Microsoft Azure Functions, Google Cloud Functions, that kind of thing. It's all about some third-party vendor managing a platform for you where you can upload tiny little small snippets of code. And the platform is responsible for all the complexities of deployment and resource management and scaling and discoverability and all that kind of stuff. And it figures out how to wire up events to your code. And you just focus on the little functions. So Amazon Lambda has been out nearly 5 years now. Microsoft and Google a little less than that. But this is functions as a service. It's half of what I talk about when I talk about serverless. The other half is backend as a service. And backend as a service is a much broader sort of idea. And it means things like Amazon S3, which I kind of think of as the original serverless service, at least the original Amazon serverless service. Auth0, which is a smaller vendor, which handles things like user management and password management so that you don't have to manage people's passwords for them. And also things like Google Firebase, which is a database that is run in the cloud that you don't have to run yourself, and is really sort of geared up for mobile application development. That's sort of its sweet spot there. So that mobile application developers can focus on building mobile apps and not have to worry about building server-side code or running server-side services. So that's backend as a service. And so building serverlessly, and some people call this servicefully, because some people don't like the word serverless, it really means outsourcing resource management, stopping thinking about having to handle resources and servers and scaling. That's when we're building servicefully, we're not thinking about those things. And also maximizing our use of hosted application services. So this is not just about thinking in functions. It's not just about using a functions platform on your own Kubernetes cluster. What really serverless is about maximizing the use of other people's services so that you have less work to do, both application development and operations. Now, there's a lot more I could say about serverless, and if you're interested, we have a book that we wrote with O'Reilly a couple of years ago, which is still in date. So we have a few of these. Grab one of these at the end. All these are available for free from our website. All right, so let's get on to patterns. What are patterns? Now, many of you here this is a software architecture conference, so many of you here have probably come across patterns before. I first came across patterns in the late 90s. There was a book called Design Patterns that some of you will have heard of, possibly even read, by a group of authors that got known as the Gang of Four. And design patterns was really all about how are we more effective in building object-oriented software. So it talked about a number of things like singleton and facade and bridge and a whole bunch of other things as ways that we could be more effective building specifically object-oriented software. So let's drill into that a little more. Here's a quote from Martin Fowler that he gave in an article in the early 2000s. He says in this article that patterns identify common solutions to recurring problems. And an important point here is that this is not a one-off solution that someone thought was clever. This is about seeing where there are common solutions to problems that we see in a number of areas. Another sort of way of thinking about patterns, this comes from a book called Enterprise Integration Patterns, which was also from the early 2000s by a couple of authors called Gregor Hope and Bobby Wolf. One of my favorite patterns books, this. And they say in the introduction that patterns are a proven way to capture expert knowledge in fields where there are no simple one-size-fits-all answers. There's a heck of a lot I could just unpack from this one sentence. But again, the point here is it's not about sort of an invention. It's about uncovering something that's already been done before. And the other factor here is that there is no simple one-size-fits-all. This is not something that is always going to be true. What it's saying is that in a certain situation, this is a technique that has been found useful by a number of people, but it's not anything stronger than that. And a way of saying that more clearly is that patterns are not best practices, right? When you're using patterns, you have to have your analytical brain on. You have to be thinking, okay, is this the right thing to use in a particular situation? It's not saying you should always do this or always not do this. So what is in a pattern? Well, first of all, there is a name. And in some ways, the name is almost the most important part. Because of things like books like Gang of Four, conversations that we can have as software designers are a lot shorter and a lot more efficient than they would be otherwise. Because I can say to you, oh, so we're going to put this singleton in our code, and you know immediately that I've made a terrible decision. Right. And you all laugh because you know what singleton is. I don't have to explain what singleton is. I can just say that one word, and you all know, or those of you that know what singleton is know. And so it's a really great way of making our communication more efficient. And when we group a bunch of patterns together, what happens is we form this really interesting vocabulary because we can combine patterns together into one solution, and it suddenly was like, oh, that's how these things can come together. So names are hugely important. Obviously, it has an implementation. What is the pattern? And then finally, it talks about the problem it solves. And there's two important parts here. First of all, when is it useful to use this pattern? And when isn't it useful to use this pattern? And so if you see a collection of patterns and all they talk about is when they're useful, ask again with your critical analysis brain on, okay, but tell me about when I shouldn't use these things. Okay, so that's patterns. But today I want to talk about serverless patterns. And I said that this talk is the awkward early years. So this is not just me wanting to give a massive out because I've never given a patterns talk before. There's a reason that I called this that, right? What is the reason? Well, first of all, serverless is new enough that we're still learning new ways of doing things. Serverless is actually a very different way of building software than we've built software before. Even more different than the move to containers and then the move to things like Kubernetes. Those are really an evolution from VMs, which are an evolution from just running things in one process. Building things serverlessly or servicefully is a very, very different paradigm. And we're still learning what to do with these tools. And even when we have learned how to do something, serverless is new enough that we're still forming opinions of what solutions are common. Remember earlier I said that a pattern is a common solution. It's not a one-off. It's not someone coming up and saying, aha, I've come up with this clever idea and thou shalt all use it. It is about saying, okay, what is a common solution? And serverless is new enough we're still trying to figure out what those common solutions are. But I think that we are now starting to know enough about serverless to get started. Serverless is really a thing that people have talked about. It's about 5 years old now. I first wrote about it 3 years ago. And so we're starting to get an idea of what things are common. And even if they're not common, we can at least start talking about things that can provoke a conversation. And in the patterns that I'm going to present today, almost all of these are things that I've seen that more than once. There may be one or two where I'm being a little bit, presumptuous. And I think actually all the ones I'm going to talk about I've seen before. The slides for this, by the way, if you download the slides from my Twitter, you'll see a few more patterns in here. I'm going to talk about 8 patterns, but the slides have about 15, so you'll see a few more in there. Before I get into the specific patterns, though, one thing I want to talk about are the categories of patterns. So it turns out just saying serverless patterns is a little bit vague. And that's because serverless really impacts the entire software development lifecycle. And what I mean by that is, first of all, it gets involved right at the beginning when we're trying to figure out, okay, how are we going to solve a problem? What technologies are we going to use in the solution of a problem? It impacts there. It's like, well, are we going to solve this serverlessly, or are we going to use traditional techniques? And what this means is, what are good application patterns? What are good examples of applications that we can solve using serverless technologies? Or even if maybe not a whole application, what if we got a particular feature within an application? Is that a good way of solving? Is serverless a good way of solving that particular feature? So first of all, when we're mapping out solutions, we have a couple of different sets of patterns there. Then we get into design. And design is obviously involves architecture, so there's going to be some architecture patterns. But also, there's going to be lower level than that, like when we're sort of getting into the smaller level code detail or lower level architecture, these service and function patterns that we'll talk about there. But serverless isn't just about this front-loading part. It's also about the active engineering. So when we're doing software development, how are we working with this stuff? And then when we're doing operations for serverless, what are patterns of doing deployment and monitoring? So as you see, serverless is more than just architecture. And so I want to sort of take a breadth-first approach to all of this today. And what I'm going to do is I'm going to present you one pattern from each of these areas, except one area where I give 2 because I liked them so much. And the other thing I want to say here is I'm going to be using Amazon Web Services as an example here. And that is because I have spent the last 5 years, 95% of the last 5 years working with AWS. And so I know AWS far, far, far better than I know Microsoft or Google. Most of this stuff is going to be applicable to Microsoft and Google. I just don't know the words to give you. Some of the things may be particularly nuanced to Amazon, but most of it will be general. Most of this stuff will not be relevant if you are self-hosting a functions as a service framework on your own Kubernetes stuff. This is really all about vendor-hosted serverless. Okay, so you ready? Let's look at some patterns, shall we? So the first one I want to talk about is an application pattern, and this is Serverless API. So what this is solving, this is the when to use it, is how do I build an HTTPS API without having to consider resource management or scaling concerns? So how do I capture some of these benefits of serverless when I want to build an HTTPS API? Now, this API could be an internal API, one that is called by other services in our ecosystem, or it might be an API that is external. It is one that is called by other partners or by our front-end client applications. This is sort of a common pattern to all of those type of things. And how we build this is going to look typically a bit like this. So on this diagram, I have on the left-hand side is a client or a bunch of different types of clients, so mobile clients or tablets or smartphones. And they are going to communicate. They're going to make an HTTP request, and the component that's going to be the first part of the chain here is what we call an API gateway. And Amazon have an implementation of an API gateway that they call API Gateway, very confusingly. At least it does what it says on the tin, I guess. Now, API Gateway from Amazon is itself a serverless service. It is a back-end as a service. It has all the traits of a serverless service in that it scales for us. We don't have to run any servers. But it handles this HTTP-ness. You can think about it like a serverless Nginx or a serverless HA proxy. You're not running an API gateway server. You're just saying, here is the configuration I want. And so API gateway is a back-end as a service. And that is the thing that's hosting our HTTP and handling our SSL termination, all that kind of good stuff. Now, obviously, we need to have something that's going to implement our routes in our API. And typically, in an AWS world, that's going to be Lambda. So you're going to have Lambda functions sitting behind your HTTPS API gateway. But you don't have to use Lambda behind API gateway. You can also do things like connect it straight up to something like DynamoDB, Amazon's NoSQL database, and perform basic translation of requests within the API gateway itself. Now, there's schools of thought about whether that's a good idea or not, but this is part of this overall application pattern. And then finally, represented on the bottom here, you can call your back-end services that haven't been exposed in this way before, and again, use your API gateway as a proxying and translating layer. So when wouldn't you use this pattern at all? So as I said before, it is important when we're talking about patterns to think about when not to use it, just as much as when to use them in the first place. So where would we not use this? First of all, if latency concerns are not compatible with present-day capabilities, then don't use this. So I used to work in high-frequency trading about 7 years ago, and I cared about 4 nines sub 5 milliseconds, right? If I had 4 nines sub 5 milliseconds, I probably wouldn't use this technique. So for extremely low latency requirements, you wouldn't want to do this. And you also, if you have throughput which is very, very high, then it might be too expensive. But there's a very important thing to remember here. When you're thinking about serverless costs, you need to be thinking about total cost of ownership. So that's not just the infrastructure cost. It's also how much labor is involved in managing a solution. Serverless is very cheap when it comes to labor costs. But at high throughputs, it can be more expensive. What I'm sort of talking about here is if you've got 1 billion requests a month or so going through your API, billion with a B, then start thinking about costs. That's sort of my rule of thumb. So that's my first pattern. So let's sort of step down a level from overall applications and just think about a feature for a second. And the first one I want to talk about here is what I call ephemeral media transformer. What do I mean by this? How do I have a highly scalable capability of processing media files without having to constantly run servers? And by media files, what I'm talking about is images or videos or sound files, that kind of thing. Now, this is sort of serverless pattern 101. This is what Amazon led with when they announced Lambda 5 years or so ago. And the idea here is that you have some kind of user client. Again, it may be a mobile app or a single-page web app, something along those lines. And it is going to upload a media file, so a video or a picture, directly to some kind of object storage in the cloud. And that can be made secure using things like signed URLs. Now, once it's been uploaded to something like S3 in the Amazon world, then that can be configured to trigger an event that will call Lambda. Your Lambda function then is told about this media file being uploaded, and your Lambda file can then process that media file, outputting a new one into a new location. And this is great, because here you don't have to run a server constantly all the time listening to these, polling for these updates. And even better, if you suddenly get a whole massive flow of these things coming up, you don't have to over-specify or over-resource allocate your resources for this. So it's a wonderfully scalable way of solving this problem. A point to mention here is that we're assuming in this solution that we have a Lambda function. Well, sometimes you might not need a Lambda function. There might actually be another back-end service that can do that for you. So for example, if you're uploading videos and you want to convert your videos to a different format, then Amazon have a service called Elemental Media Convert that will do this for you. So you don't even need the Lambda function in that situation. And that's important because when we're thinking servicefully, when we're thinking serverlessly, we're trying to maximize, again, the amount of third-party services so that we can reduce the amount of work that we do. So when wouldn't we do this? First of all, we wouldn't do this if our files were too large, if we were using the Lambda-based solution, because there are limitations right now with Lambda, for example, where you can't run a Lambda for longer than 15 minutes. So if you had a massive, massive file and what you were going to do was going to take half an hour, then you couldn't use Lambda, or at least not a simple solution like this. You also wouldn't use this if you had a particularly complicated or nuanced workflow. Although you might adapt this to use something like Amazon step functions. And you wouldn't use this particular way of working if you needed something far more real time. So you're going to see a latency of a few seconds with this kind of flow, maybe like 2 or 3 seconds. If you needed something sub-second back to the user, then you probably would want to use something a little bit different and something that was more synchronous. So this is an inherently asynchronous event way of working. So again, it's a great pattern, but you're not going to use it in all situations. All right, this is an architecture conference. Let's talk about architecture, shall we? So the first one I want to talk about here is serverless application, which sounds so generic as to not mean anything, right? So I'm going to sort of be a little more clear about what I mean by this. So when some people first come across Lambda, and all these little tiny functions that do one specific thing, they are worried that it is going to mean a Cambrian-like explosion of individually managed components across their organization. And how the heck are we going to look after all of those things? Can we bring some order to this chaos? Well, yes, is the answer. And a way of thinking about this is using this model of serverless application. And with serverless application, what we do is we can consider a number of different components as one deployable unit. So in this example, what I've got is 3 Lambda functions in the middle. I have an API gateway on the left-hand side, and I have a DynamoDB instance that those 3 functions are all using. And I'm deploying that as one unit. And this is very like microservices. This is very like the idea of having a microservice with an encapsulated database, where you have a microservice, it has its own database, and you deploy them as one unit. This is the same idea as that. And in fact, you could consider this a serverless microservice. And a lot of people go, OK, well, so serverless means nanoservices. No. You can build microservices using serverless technologies. And this is an example of how you would do that. I want to call out a couple of other things that I think make this pattern particularly powerful. And one is on the bottom left. There is this little weird icon that in Amazon speak represents CloudFormation. CloudFormation is Amazon's infrastructure as code solution. And the point being here is not only do we have the functions here sort of being related to each other, we have an application template that has all of those things in one template or maybe 2. But the point being, we bring those together, we reify this grouping by means of an application deployment template. The other part I want to call out is on the bottom right, we have some other icons here that represent operations. So we have here log groups and metrics and alarms and dashboards. And we can deploy our operations constructs with our application constructs, again, as this one application. So instead of the operations parts coming as an afterthought later down the pipe, we can bring in our operations resources as first class within our application deployment. OK, so that's serverless application. When wouldn't we use this? Well, if you're performing a really small integration between 2 different components, and this is a very common thing, especially when you're using Lambda as an operations idea, then don't try and force arbitrary grouping of a whole bunch of 5 different Lambdas just because you're worried about one Lambda being deployed by itself. It is OK to deploy a Lambda by itself if you have an app and it just has one. So don't force yourself into thinking you can only deploy 5 Lambdas at a time. But that's sort of really the only place I'd say don't use this. When I'm working with Lambda and serverless technologies now, I'm always thinking about this whole idea of the serverless application. I want to give you a second architecture pattern here. I call this client service. So when I first came across serverless, I thought it was primarily about systems using AWS Lambda or equivalent. And then about 3 years or so ago, I saw a talk by a guy called Joe Emerson. And he talked about building complete applications with zero server-side code. And I wondered what the heck I'd walked into. Like, how do you build real apps, real profit-making apps where you don't write server-side code? I've spent my entire career writing server-side code. And it turns out you can. And in fact, this is what Joe thought serverless really meant. It means no servers. I'm like, oh, that's interesting. So this brings up our next pattern. How do I build an application where backend as a service services satisfy all of my server-side needs? What if I don't need any server-side code? It turns out you can do this today because we have modern, secure ways of having HTTPS accessible services. So for example, with a mobile app, you might log in using a service like Amazon Cognito, and that gives the front-end credentials to be able to access in a secure way things like a database or an S3 bucket or whatever on the back end. And this makes an incredibly powerful solution. This is also the same basis of techniques like Google Firebase, and before that, an application called Parse, or a service called Parse. So when wouldn't you use this? Well, you wouldn't use this if you actually wanted to write some server-side code, right? That's fairly obvious. But you can kind of use this. Like, I really strongly encourage people these days to sort of think about how can we push as much logic as we can up to the front end and then rely on backends, calling backend services directly from the front end. And so the idea of using a hybrid approach of the client service with backend serverless functions as well. Okay. Sort of get down a little bit again on the design side into service and function patterns. Now, this is where we've been seeing a lot of activity in defining patterns in the serverless world. On my Twitter that I talked about, there is a resource document with a bunch of links, and some of those links are off to people who have been talking about these kinds of patterns. So if you're interested in this stuff, go and look at that. I'm going to give one example right now, and this one is called idempotent function. So this is getting a little bit heavy now, but for those of you that have used Amazon Lambda a little bit, you may or may not know that Amazon guarantees that for every event that happens that is tied to a Lambda function, it will call your Lambda function at least once. It may occasionally call it more than once because of the wonders of distributed development. That's a slight joke. But the point being that you need to know that your Lambda function may be called more than once for the same event. And so how do you work with that? How do I guarantee that there is at most one side effect for each event that triggers a FAS function? Well, one thing that Amazon do guarantee is that if they do call your Lambda function twice for the same event, that they will use the same request ID on the event that is called, on the event when it calls Lambda. And so you can use this along with a feature of DynamoDB called conditional writes to basically bring a sense of atomicity and transactionality to what you're doing. I'm not going to get into the details here, but the idea being that you may call your Lambda 3 times, or your Lambda function may be called multiple times to the same event, but you can guarantee you only actually have one downstream impact. Now, one of the reasons I wanted to talk about this pattern is I think it's a great pattern in a very small set of circumstances. I think there are many, many times where you wouldn't want to use this pattern. So, for example, if your side effect downstream can be implemented in an idempotent way itself, in that you can call your downstream systems multiple times with the same inputs, and it will have the same behavior as if you'd just done it once, that's a much, much better way of solving this problem. If you can't solve that, then maybe it turns out that duplicated side effects are no big deal. Maybe you're going to just send 2 emails rather than 1 to an internal team. And if that's the case, you know what? They can probably just get 2 emails, and that's fine. And then finally, maybe you have a massively high throughput system and you want to do something differently. So this is sort of an example of a pattern that is absolutely brilliant in a few cases, but it shouldn't necessarily be one that you reach for immediately. okay, I want to get out of the design area and now more into the process of actually developing and operating serverless systems. So I talked a little bit earlier about this idea of serverless application, grouping a number of functions together. And a typical question that I get asked when we're building things in that way is people say, how am I going to organize my source code? Am I going to need one GitHub repo for each of my Lambda functions? Because that sounds like an absolute nightmare. Spoiler alert, it's an absolute nightmare. So don't do it. What do we do instead, though? Well, I think it's interesting to sort of bring some of the ideas of monorepos, but into building one of these serverless applications. So how do I set up a source tree for a collection of FAS functions in a way that we can still share code across those FAS functions? But another important thing that we don't want to do is overly inflate the size of our Lambda function artifact. Because when we do that, deployment time gets slower and development cycle time gets slower. So we want to keep our function artifacts really small. So the way that we can do that is we can have a source tree, maybe a repo for our serverless application. And we'll have a subtree within there for each of our Lambda functions. And those subtrees may be able to reference common code in the same repo. But importantly, each of these Lambda functions will have their own dependencies, their own library dependencies. So we don't have to take the union of all of the library dependencies across our application. We can just have, for each Lambda function, just have its own. And then what happens is we build an artifact, a deployable artifact for each of our different Lambda functions. And then our deployment template that we talked about earlier, every serverless application has one deployment template. The deployment template will then reference each of the built artifacts, the built zip files for each of the Lambda functions that we have. And so this solves the problem of we have one tree for all our Lambda functions, but we have different distributable artifacts so that our zip files don't get too big. Okay, so when do we not use this? This seems like, well, you would always use this, right? Well, obviously, if you're not using the serverless application pattern, then this wouldn't really work. This is really built for that. It's really sort of a derivative of that serverless application pattern. But also, if you're already working in a large monorepo way, you can probably just carry on working in a large monorepo way. You don't have to throw all that away when you're working in a serverless way. And try and combine some of those monorepo techniques to do something to solve this problem in a similar way. But a final place I wouldn't recommend using this is if actually you can fit all of your Lambda function code for multiple Lambdas in one zip file, and that zip file is just, a few hundred K, then just have one zip file for your entire application, right? Don't over-engineer here, because what you're doing is you're going to have longer build times to create all of these zip files, and so you're optimizing for deployment speed. But if you can not have to do that, and it's actually a reasonable size zip file for all of your Lambda functions, then just do that. I want to talk about a deployment pattern here. Most aspects to serverless deployment are actually just AWS deployment. There's nothing really that particular. But there's one that I've been using a lot this year that I think is extremely powerful. And this is using an AWS service called the Serverless Application Repository. And what this is trying to solve is it says, how do I create a component with its own infrastructure definition that solves a recurring problem, and then share that component with its infrastructure within multiple applications? So what Serverless Application Repository allows us to do in this top left area is build a mini serverless app. And we define that with a template just as we would do with any other serverless app. And we build it and we package it. But instead of deploying that app, we publish it to this thing called the Serverless Application Repository. And then other applications can consume that component and embed it within their own applications. And it's like using a library, but it's a library with infrastructure tied in. And it's this really, really amazing, like once you start using it, it's this incredibly powerful way of building small components. These components might be, for example, one of the things I've been using this a lot is I wrap up all of my monitoring behavior that I want using API Gateway with alarms and alerts and dashboards. And I build a published component with all of that infrastructure and a couple of Lambda functions. And I publish that as a component into SAR. And then my actual APIs will then define, hey, I want to use that monitoring thing. And they define that within their template, and then they can just deploy as normal. It's just as if they put all of those resources in their own application, but we're importing that just like we would do a library. Very, very powerful. When wouldn't we use this? Well, if you don't have access to the serverless application repository or an equivalent, then you wouldn't be able to use this. But also, even the serverless application repository has restrictions about the type of components that you can include within it. So you can't, for example, say, spin up an EC2 instance as part of a SAR app right now. You can do many, many other things, but there are restrictions about the kind of service that you can include. OK, so finally, I want to talk about monitoring. And again, monitoring is not really, there's nothing really specific. There's very little that's specific to serverless. There's a few things with third-party tools that are very geared around Lambda, which are excellent. But there's a lot, certainly in Amazon's world, you're using the same techniques that you're using when you're building a cloud-native application on Amazon in general. But serverless does force focusing on a few areas. And one I want to talk about here is use of a particular Amazon technique. And I'm calling this pattern log-sourced metric. So the problem this is solving is, how do we capture application metrics from our Lambda functions or our other FAS functions when the metric collection service that we want to use may not actually be able to handle the same scaling behavior that we see in Lambda? And this is a true case. So for example, in AWS, you may use AWS CloudWatch metrics as your metric solution. And you can publish custom application metrics to CloudWatch metrics using put metric or whatever the API is called. The problem is that CloudWatch metrics won't scale quite as easily as Lambda will, and you can actually overload CloudWatch metrics with your limits from Lambda. And it's strongly recommended, in fact, if you're using Lambda, that you don't call put metric directly from a Lambda function. OK, but how the heck do we get metrics in? How do we create application metrics? Well, fortunately, there is a well-defined solution. In an AWS, it's called using a CloudWatch metric filter. So the idea is that you take your metrics in your Lambda function, and instead of publishing them to your metric provider, you log them using structured logging to your regular log stream. And then you define, using a CloudWatch metric filter configuration, a particular expression that will pattern match on that particular log, and it will be able to extract the metric that you published, and it will then be able to publish that metric to CloudWatch metrics on your behalf. So combination of CloudWatch metric filters and structured logging solves this for you. So when wouldn't you use this? Well, if you're using a vendor metric system that does scale, and some third-party Lambda monitoring and metric systems do scale a lot better, then you don't have to worry about this. And some of those things may be implemented using sampling. And then also, if you don't actually want to capture application metrics from your Lambda function, then don't do this. Like if you're building a Lambda function it's not particularly important, or it's very low throughput, then maybe using the metrics that come with the Lambda platform by default, because Lambda gives you 8 or 9 different metrics like errors and throughput and that kind of stuff. Maybe that's sufficient. And if it is, again, don't over-engineer. Just because this sounds like a cool pattern, it might not be useful in your particular scenario. OK. So those are all the patterns. If you download the slides online, you'll see that there's a few more as well that I've detailed. But sort of close out, I want to talk about something else, which is sourcing your own patterns. So I said at the beginning that we're all still trying to figure out what patterns are in this world. So when you're sourcing your own patterns, look for solutions that you see repeated in your own organization. And you're going to have to put effort into this. There's a lot of organizations I find where there's a lot of Lambda activity going on, but teams actually don't know about it because it's so easy and small to do. So you actually put a bunch of teams in a room, and you might find out that all of you are actually solving similar problems in the same way. So look for solutions that you see repeated. I invite you to use these 7 different categories that I talked about to help you narrow down your search. And remember, when you're building these patterns, that it's useful to know when they're useful, but equivalently when they're not useful. When should people think about not using this particular solution? So to sum up, as an industry, we're still figuring out common patterns of serverless. It's still new. We're still figuring out how to use these tools, and even when we have figured out something interesting, when is it a common solution? But we do have some ideas now. I've shown you some today, and in the resources, as I mentioned, there's a few other folk in the industry have also been coming up with some ideas here. I think it's useful to break serverless up into these different activity categories. Part of it is about architecture, but part of it is about operations, and these are very, very different things. But there are patterns that we can get from those different activities. And I did show you a few patterns that I hope will get you started as you're sort of delving more into serverless. And thank you very much. We do have time. Wow.
5 minutes for questions.
OK.
You talked about the mini mono repo. Have you used the Lambda layers as a way to package that and successfully used it?
The question is, have I used Lambda layers? So Lambda layers is a feature of the Lambda platform that allows you to extract certain logic into a distributable that's common across a whole bunch of Lambda functions. I don't think Lambda layers are good, as a rule, for packaging application logic. Because they're really only enacted at deployment time. I think that Lambda layers are really useful where you have something that is sort of platform-like and typically has some amount of binary dependency on the system. So if you're using like a common Unix library that you want to import and make available, and it's a large library that is going to slow down your deployment time, I think layers are great for that. I don't think that they're a good way of encapsulating application code that frequently changes, because it just makes testing harder.
Thank you.
Have you used Lambda step functions, and do you have any pitfalls or best practices that you probably could share with them?
Have I used step functions? I have used step functions. Step functions is a really interesting service. Those of you who haven't used it, it's basically state machine as a service. You define your state machine, and then that state machine can trigger Lambdas or can trigger other things, and it's a way of parallelizing requests and waiting for them. I think step functions is really useful. It's in certain situations. My caveats with step functions are that it's a little hard to test because you can't really test it locally. And also at really high throughputs, it gets really expensive very fast. But for more sort of procedural things that you're doing on a, in a scale that you can think about as a human being, as opposed to 1 million times a day, then I think that it's definitely worth investigating. Way at the back.
Did you have a chance to host C#.NET Lambdas, and how did you manage cold starts?
Have I implemented any C# Lambdas? No, sadly, although I'm very, very glad they exist. About 15 years ago, I used to be a Microsoft MVP, so I have a long ago history of using C#. I haven't used C#, but my techniques for trying to improve cold start times with C# would be the same as Java or any language, which is to try to minimize the dependencies that I was bringing into my code to be only what I need. So one thing that's sort of common with Lambda development is we've got used to building these massive, massive distributions that are maybe more than a gigabyte in size. That really doesn't work with, that actually literally doesn't work with Lambda. You can't have a distributable that's more than 50 megabytes compressed. But even then, because Lambda is an ephemeral platform, really restricting how much code you're deploying to just the code that you need is going to help you out. In Java land, we can do tree shaking to try and sometimes break down the libraries into just the code that we need. If there's something equivalent in .NET, I would look to see whether that was a possibility.
Just one more.
Hi, my question is, actually, can you give us some examples of cost savings you've seen by using serverless?
Examples of cost savings that I've seen using serverless? Yes. So when my business partner and I first started using Lambda and Kinesis, which was, how long ago was that now, John? 3.5 years ago, 4 years ago, something like that. We were running on these really, really, really hefty R3 8x large instances, which were very, very expensive. And the reason that we were running those is because we had a traffic pattern that would spike up and down. And so we couldn't really have auto scaling with that solution. And so we had to specify our resources for peak load. And even then, we wouldn't always be peak load. By using Lambda, we'd only ever be charged for what we were doing. Now, I can't give you a like-for-like numbers on here because we completely rebuilt the entire system, and some of the cost savings were from efficiencies that we brought in. But there's no question that was cheaper. I think the most common thing is where someone goes from like running an EC2 instance just to realizing that they can just handle like 10,000 Lambda invocations a day, and then you can just do the math and go, oh, this is like 1%. And then the other thing which goes hidden is, and this is where people sort of forget when they're doing the math on Lambda, is you don't have to worry about that unintended operations work that you have to do if you're running your own servers. So for example, like a year and a bit ago when those CPU bugs came in on the Intel chips, like 18 months ago, like everyone that was running their own container clusters had to bring everything down and restart with the patches that came from Intel or whatever. Amazon just updated all of the Lambda functions at runtimes overnight, and there was no work for anybody to do. And so the amount of operations cost savings that you get that sort of is just leaks through the cracks otherwise is significant. I think we're out. Thank you so much for coming, everybody.